Hello everyone, I am Golden Ashwini. I am here to present addressing modes in computer architecture and organization. So addressing modes. Each instruction of a computer specifies an operation on certain data. So the different ways in which the location of an operand is specified in an instruction is called as addressing modes. So different operands will use different addressing modes. So one or more bits in the instruction format can be used as mode field. So the value of the mode field determines which addressing mode is to be used. So the effective address will be either main memory address of a register. So the most common addressing modes are immediate addressing modes, direct addressing mode, indirect addressing mode, register indirect addressing mode, displacement addressing mode, and stack addressing mode. Immediate addressing mode. So in this, actually it's a simplest form of addressing. Here the operand is given in the instruction. So this mode is used to define constant or set initial values of variables. Then the advantages of this mode is that no memory reference other than instruction fetch is required to obtain operands. The advantages is that the size of the number is limited to the size of the address field because most instruction sets is small compared to word length. Example, add 3. Actually add 3 contains content of accumulator and 3 is operand. Then direct addressing. In direct addressing mode, the effective address of the operand is given in the address field of the instruction. So it requires one memory reference to read the operand from the given location and provides only limited address space. So length of the address field is usually less than the word length. Example, move p comma r naught, or we can say add q comma r naught. So where p and q are the address of operand, r naught is any register. Sometimes accumulator is a default register. So then the instruction will looks like add a. The next one is indirect or pseudo direct addressing mode. So in this addressing mode, the address field of the instructions refer to the address of the word in the memory, so which in turn contains the full length address of the operands. So address field of the instruction gives the memory address where on the operand is stored in memory. Then control fetches the instructions from memory and then uses its address path to access memory again to read effective address. The advantages of this mode is that for the word length of n, an address space of 2n can be addressed. The advantages is that the instruction execution requires two memory references to fetch the operand. Multi-level or cascade indirect addressing mode can also be used. Then the next one is register addressing. In this register addressing mode is similar to direct addressing mode because the only difference is that the addressing field of the instruction refers to a register rather than a memory location. Here 3 or 4 bits are used as address field in the instruction to refer 8 to 16 general purpose registers. The operand are in the registers that reside within the CPU. The instruction specifies a register in the CPU which contain the operand. There is no need to compute the actual address as the operand is in a register, and to get operand there is no memory access involved. The advantages of the register addressing are small address field is needed in the instruction and faster instruction fetch. The disadvantages included very limited address space and usage of multiple registers helps in performance, but it complicates the instructions. Then register indirect. In this register and indirect is similar to indirect addressing mode. The address field of the instruction refers to a register. Refers to the registers. So the instruction specifies a register in CPU whose content gives the operand in memory. The selected registers contain the address of the operand rather than the operand itself. So the register contains the effective address of the operand. This mode uses one memory reference to obtain the operand. Then control fetches the instructions from memory and then uses its address to access register and looks in a register or for effective address operand in memory. So the address space is limited to the width of the register available to store the effective address. Then the next one is displacement addressing. So it is actually combination of direct addressing or register indirect addressing mode. It requires that the instruction have two address field, at least one of which is explicit, means one is address field indicate direct address and the other indicate the indirect address. Then the last one is stack addressing mode. The stack address is actually a linear array of locations referred to as a lost in first out queue. So the stack is reserved blocks of locations appended or deleted only at the top of the stack. So stack pointer is a register which stores the address of top of stack location. So this mode of addressing is also known as implicit addressing. Okay, thank you. Thanks for